Section 3.5b is about solving equations again with variables on the right and left, but now we're going to add grouping symbols to the mix and see how that changes things. On the left side of this equation, you'll notice there's a 1/3 times an entire group. Well, we have to get rid of these grouping symbols, and the way that we've learned to do that is to use the distributive property. So I'm going to distribute the 1/3 to both of these terms. You don't have to write this next step out if you don't need to, but I'm just going to write it to help those that really don't quite understand the distributive property yet. So really I'm going to multiply 1/3 times 18, and I'm going to multiply 1/3 times 12q. Well, let's see what happens when we do that. This is really an 18 over 1, and I can cross cancel 3 and 18. 3 will go into 18 6 times. We end up with a 6 on top with a 1 on the bottom, or just a 6. Over here, 12q over 1. 3 goes into 12 4 times the q. So this really is just a 4q. So by distributing the 1/3 to each of those terms, I end up removing the parentheses. Now I'm going to do that same thing to the right side. This one's a little easier. 6 times 2q is 12q. And 6 times -7 is 42, -42. Now that the grouping symbols are gone, we're left with an equation like in section 3.5a, where there's variables on both sides and we just have to solve that. I'm going to move the one with the smaller coefficient by subtracting 4q. So what will that give me? 12q minus 4q is 8q. The rest of it gets rewritten. I have a 6 over here on this side of the equal sign and a minus 42 here. Now I'm going to isolate the q, doing PEMDAS in reversed. I'll deal with subtraction. And so if I add 42 to -42, those will give me a 0. That means I have to add 42 over here. So 48 equals 8q. And then 8 is connected to the q with multiplication. I'll get rid of that with division. So 48 over 8 is 6. Here's another example to solve using grouping symbols. I'm going to take this 8 and I'm going to distribute it to each term inside of the parentheses to remove the grouping symbols. 8 times 5 is 40c, and 8 times 2 is 16 with the minus there. Now I'm going to distribute the 10 to the second set of grouping symbols. 10 times 32 is 320, and 10 times 4 is 40 with the c. Now I want to get all the c's together, so I'm going to move the one with the smaller coefficient. Well, it turns out they're the same, which is going to be interesting for us here, because as we take 40c minus 40c, we get a 0, leaving us with -16. Over here, 40c minus 40c, that's also a 0, leaving us with 320. Notice what happens. The variables are gone. There's no variable left for us to solve for. This brings up a special situation that you're going to have to be familiar with, and I've made a separate sheet here to talk about that. If the variables cancel off, there are two possible solutions. One, if the equation is a true equation, then your answer is going to be all real numbers. There's a special symbol we can use to write that as shorthand. It's a capital R with 2 lines on the left side. That stands for all real numbers. That means that any number in the world will work in that variable. The other possibility is if the equation is false, there is no solution, and the special symbol that we can use for that is a 0 with a slash through it. Now you could write the words, all numbers or no solution, or you could use the symbols. These are the two possible answers when the variables cancel off completely. So now let's go back to our example. Here the variables canceled off. So it's going to be one of those. It's going to be either no solution or all real numbers. Well, which is it? When the equation is false, in this case, -16 does not equal 320. This is a false statement. We can even write that here. This is not true. -16 does not equal 320. Well, then the answer is no solution. That means that there is no number that I can put in for this c that will make this true. You could also use the 0 with the slash through it, either one of those. But the important thing to remember is this idea of what the possible solutions are when the variables cancel off, and then to choose the one that fits the equation. Here we have another equation that we have to solve that uses grouping symbols. So I'm going to start by distributing the 4 here. 4t plus 80, getting rid of the grouping symbols. Now I'm going to distribute the 1/5. I'll write this out like I've done in the past just to help those of you with fractions. So this is really 1/5 times 20t and 1/5 times 400. Don't forget that each one of those is a fraction, 20t over 1. So 5 goes into 24 times, leaving me with a 4t. over 1, which is just 4t. Here 5 goes into 480 times. So we end up with 4t plus 80 equals 4t plus 80. Now you might recognize right now that both of these sides are exactly the same. If you didn't, you'd probably continue to subtract 4t. You would wipe out those variables, and you get 80 equals 80. And now we have to go back to the last slide that we looked at. We have a situation where the variables canceled off, so we're back to this idea. Now if the equation is true, it's going to be all numbers. If the equation is false, it's going to be no solution. So let's go back and look at the equation. 80 equals 80. Well, that's true. So what's my solution? All real numbers. That means that any number in the world, if I plug in, will make this true. Now this has a special name. This is called the identity. If you get a solution in which all the numbers in the world will work, it's called the identity.